Welcome to Math Master. This is Saritha. Today our topic is different types of operations on algebraic expressions. Okay, operations. We have different types of operations in algebraic expressions. Those are addition, subtraction, multiplication. Okay, so for our first operation is addition. We know what is the addition of given numbers, but now we will learn what is the addition of two algebraic expressions. If you take two algebraic expressions, how to add those two? So what we have to do? We have to do is simply add the like terms. Okay, add the like terms and write the remaining terms as it is. Okay, so you take one example. So let us consider A is one algebraic expression and this is equal to 3x square plus 2x plus 10. Okay. And B is another algebraic expression. So which is nothing but 7 plus 4x plus 2x square. Now how can we add these two algebraic expressions? So what we all need to do is add the like terms. First you write the algebraic expression in the order of descending order of their degrees. The terms, you write the terms according to the descending order of their degrees. So 3x square, next 2x plus 10. Then you write the second algebraic expression exactly below the first expression. So this is nothing but A, and you write B below of it and you write the like terms below of it. So x square term we have to write below of this term, which is nothing but 2x square plus 4x plus 7. Now you add A plus B, which is nothing but addition of these two algebraic expressions. That is what we are saying. We are doing simply adding the like terms. See, x square. These two are like terms. Yes, these two are like terms. So what we need to do is simply add the constants, numerical coefficient. Okay, so add these two numerical coefficient, which is 3 plus 2 is equal to 5 x square. Next, add these two, 6x plus 17. Okay, so this is the addition of two algebraic expressions. Now, we know very well, for this expression we can calculate degree. Okay, and for this expression also we can calculate degree. What is the degree of this expression? 2. Okay, the maximum of the degrees of all the terms. Okay, so which is nothing but 2. And if you take B expression, see, for this also the degree is 2. If you add the two algebraic expression, then what will be the degree of those two expressions? If you consider two same degree expressions. Okay, so now we have to define what is a degree of addition of two algebraic expression, and I am considering the first case as a same degree expressions. This is a 2 degree expression, this is also a 2 degree expressions. Now we are adding these two. So what is the degree of this? What is the degree of this? So the, if you add, what happened? 5x square. So x square is the exponent 2 is the maximum of all the terms. That is why the degree of a plus b is what? 2. If you take this as a minus 3x square. Now you add these two expressions. What happens? If you add these two expressions and these two are like terms with different signs. So what happens? These two gets cancelled. Then what will be the a plus b expression, which is simply 6x plus 17. Now tell me, what is the degree of this expression? Even if you consider two algebraic expression of same degree, but we got the expression which is less than the degree of individual degrees. Yes. So what is the degree of a plus b here? Degree of a plus b, which is equal to 1. Okay. Now take one more example, that is this I am considering minus 2x. Now you add. What happens? These 2x terms also gets cancelled. Okay. So what will be the remaining part of a plus b? Which is nothing but simply 17. Now what is the degree of this? So degree of a plus b, which is equal to, what is the degree of constant term? It is always 0. See, in first case we got the degree as a 2. When we consider two algebraic expressions of same degree. Okay. So when you consider two algebraic expression with same degree, in that case we got one time as a degree of a plus b is a 2, and other time we got a degree of a plus b as a 1, and one more time we got degree of a plus b as a 0. Now how can we exactly say which one is true, means whether the degree of a plus b is 2 or 1 or 0. So that completely depends upon the like terms and the sign of the like terms. So that depends on the terms of the expressions. So that is why can we determine exactly what is the degree of addition of two same degree expressions? We cannot determine. So by this I can conclude that we cannot determine the degree of sum of two expressions of same degree. Okay. So we generalize that in terms of n. Okay. So first I am taking, let us take degree of an expression a, which is equal to n, and I am considering one more expression, that is b. The degree of b is also n. Now, what is the degree of a plus b? That we cannot determine, because these two are same degree terms. Yes, if the same degree terms, if they gets cancelled, the degree of the a plus b completely changes. So that is why we cannot determine the same degree expressions. Okay, some of the expressions of same degrees. That is why we can simply say which is always less than or equal to n. So you may get a question that if it gives this in the statement in the question, that is degree of a is equal to n, degree of b is equal to some number he gives in place of n. So let us take 10, and degree of b is also 10. Now he will ask the degree of a plus b. That time you should think twice, okay, before answering the question. So what you should answer? So that we can, if the one of the option is cannot be determined, then you should go for that. Okay. If it is less than or equal to 10 in the given options, then you go for that. Okay. So you try to think before you answer the question. So this is the generalized form when you take when you consider two same degree expressions. Okay. So now what happens if we take different degree expressions? I am considering one expression of degree m and other expression b of degree n. Now tell me, what is the degree of a plus b? What is the degree of a plus b? Here, which is nothing but the maximum of these two. See, we have seen the degree of an algebraic expression. How we define? We defined an algebraic expression degree as the highest value of all the terms of the algebraic expressions, right? So if you add these two, so the maximum degree will be the degree of this a plus b, isn't it? So that is why we can generalize it is nothing but maximum of m comma n. So okay, so we can define the degree of a plus b if their individual degrees are different. So this time we can define it is a maximum of m comma n. If those two are of same degrees, then it cannot be determined. It cannot be determined. Okay, this you have to understand. Now we'll consider some examples. I am taking one example, that is a is equal to 3x square y plus 4y square plus, and I am taking b expression as now. If you add these two expressions, what happens? The like terms x square y, these two gets cancelled. Then you will be remain with 10y square plus 7x. So now what is the degree of this expression? So this is the a plus b expression. So now this degree of this expression is simply 2, isn't it? So this is what we generalized just before. Okay, you remember that note point. Now we'll go for one more example, that is degree of an expression a is equal to 10. Okay, and degree of an expression b which is equal to 6. Now tell me the degree of a plus b expression. Okay, now what is the answer for this? So just now we said that a plus b is nothing but the degree of a plus b we can define if they are two different degrees, which is maximum of m comma n, right? So maximum of these two, maximum of 10 comma 6, so which is nothing but 10. See, if the 6 degree terms gets cancelled also, even the 6 degree terms gets cancelled, then also the 10th degree terms are available in the a plus b expression, right? That is why. So the maximum of the 2 degrees will be our answer. Okay. Suppose if you take 3 expressions, what happens? Degree of a is equal to 10, degree of b is equal to 10, and degree of some c expression is equal to 8. Now tell me what is the degree of a plus b plus c. So what happens? So there is a chance of getting cancellation of 10 degree terms, isn't it? So we have to think like that. So there is a chance of getting cancelled of 10 degree terms. So what is degree of a plus b plus c? Which is simply less than or equal to 10. So which is always less than or equal to 10. We cannot exactly say what is the degree of that. Okay. If any two degrees, any two expressions degrees are same, then that time they are always less, sum of those expressions degree always less than or equal to that number. Okay. So that time we cannot say exactly what is the degree of that expression. Okay. Second operation is subtraction. How can we define subtraction? If you take two algebraic expressions, either a minus b or b minus a. So let us take two expressions are a and b. So either a minus b or b minus a, which is nothing but difference of two expressions. We can define either by a minus b or b minus a. So that we called as a subtraction of two algebraic expressions. So we'll take one example. See, a is equal to 2x cube minus 3x square y plus 2, and b is one more expression which is 3x cube plus 2x square y minus 8. Now how can we subtract these two? So we can either define a minus b or we can define by b minus a. A minus b, which is nothing but we are subtracting this b expression from a. So that time you have to write a expression first, then you have to write b expression. Okay. Now a minus b is simply, you have to change the signs here. As it is a plus, you change the sign because we are subtracting, means we are multiplying with minus, isn't it? That is why signs are getting changed. Okay. Now you add those two. 2 minus 3 minus x cube minus 3 minus 2 minus 5x square y plus 2 plus 8 plus 10. Okay. So this is how we can define a minus b. If you want to calculate b minus a, which is nothing but we are subtracting a expression from b. So that time you write b expression on the top, which is simply 3x cube plus 2x square y minus 8. And next write a expression, that is 2x cube minus 3x square y plus 2. Okay. Now you find out b minus a, which is equal to, you change the signs here, minus plus minus. Okay. X cube plus 5x square y minus 10. You identify the difference a minus b and b minus c. What happens? The terms are same, x cube, 5x square y, 5x square y, 10, 10. So what is the main difference? Only the signs are getting changed. Okay. What all you need to observe is, if you find a minus b or b minus a, only the difference is signs are changed. Means if you want to find b minus a, it is enough to find a minus b. If you first find a minus b, then write it the same expression by changing the sign, you will get b minus a. So this you have to observe. Okay. The degree of a minus b or b minus a. Degree of a minus b. So what happens? If you take degree of a is equal to n and degree of b is equal to n. So I have considered two algebraic expressions of same degrees. What happens? Similar to the previous case, in the addition also we have seen, if you consider same degree expressions, degree of some of those cannot be determined. Similarly, the difference of the two expressions of same degree also cannot be determined. This also we can define, which is always less than or equal to n only. Means we cannot say exactly what is the degree of the difference of two algebraic expression. Okay. So if we have two expressions of different degrees, one is m and one is n, then degree of a minus b we can define, which is same as maximum of m comma n. Okay. So this is same as in the case of addition only. Okay. So we can define the degree of a subtraction of two algebraic expression when the degrees are different. So if we have same degree algebraic expressions, then the degree of subtraction of two algebraic expression cannot be determined. Okay.